Hello, my name is Stéphane Farou. I'm a French database consultant, and I'd like to talk about backups. I won't be product specific. This isn't a how-to video, more of a why video. And my aim is firstly to help you understand the docs. A friend of mine, Frédéric Brouard, likes to say that if you see a price associated to hardware in the accounts of a company, as well as to software, there is something missing that is very valuable, as some have understood: data. A major data loss can sink a company, and the people responsible for databases can expect the worst if they lose their databases and cannot recover them. What are the reasons for data losses? I've been unable to find recent figures, but usually you lose data because of primarily hardware failure, for instance a disk that crashes, closely followed by human errors, such as dropping tables in the wrong database. Far behind, you find software bugs and natural disasters. When you care about your data, you want to back up your databases. Then the question is how? A popular method is to dump the data to a file. Utilities generate create table statements from the existing table definitions, then run the equivalent of a select star against stored tables in your database, and write the output in human-readable or proprietary format to a file. As indexes contain physical addresses that will be invalidated when reloading, they are just saved as createIndex statements. Stored procedures are also saved. This is called a logical backup, because you just care about the objects in the database, not the files that store them. A big benefit is that the backup will be much smaller than the database, in which a lot of storage is consumed by indexes, the data dictionary, temporary areas for sorts, and the like. It is common that useful data represents only 30% of the database size. If your database is only used to record social events for the local knitting club, look no further. But if the pace of activity is not as sedate, there are several points to note. The first one is that you may have consistency issues. Unfortunately, backups are not instant operations. If your database is reasonably big, dumping the data may take some time. Suppose you run a merchant site. Very often, orders you take are stored into two different tables: orders that stores everything that is relevant to one shipment, and order details that will specify the various items you will send in the same box. You dump your data, and after you are done with orders, a customer creates a new order, inserting a row into order details before you back it up. Then, the same customer clicks again on Add to Cart just after your backup completes. Your backup risks being inconsistent, with one orphan row saved and the two others missing. Some products take care of consistency, not all of them. You'd better check. The second issue has to do with data loss. Your backup will save the bulk of your database. If a problem occurs some time after your backup, then you can restore what the database contained at that time. But what about all the changes that took place between the backup and the crash? The answer is easy: down the drain. Perhaps you have a paper track or files that will allow you to reapply the changes. But you can lose a lot of work. Increasing backup frequency may be a solution, but it may not be enough. The third issue is availability. When you restore your backup after a crash, you are far from done. First, you must recreate all tables and reload them. But the really painful step is recreating indexes, which can literally take hours on big databases before the service is available again. A lame apology is unlikely to make you popular. There is one radical solution. A database management system is basically composed of data files, of server processes to run queries, of a memory area in which everything happens, and of a journal that logs transactions. What you can do is to shut down everything so as not to be bothered by customers trying to buy something. This is what is known as a cold backup. And this is a physical backup because this time you will be dealing with files, not database objects. You copy the data files away, Very often people also copy log files just to make sure. Then you restart the database. How does it compare to dumping the data? Well, there is no longer any consistency issue since nobody could work during the backup. For data loss, it's the same story as before. And for availability, it's better, because when you restore, you just have to copy the files back and start up. Indexes don't need to be recreated, since rows are still at the same place in the data files. But of course, if you'll be able to restart much faster, you need to stop your database every time you back it up. That's called planned downtime, which is much better than the unplanned sort, but that you still want to minimize. There are some software and hardware solutions that can help. For instance, you can sometimes clone file systems, a very fast operation that allows you to back up the clone to tape while the database is already restarted. Or, if your disks are mirrored, you can break the mirror when the database is down, restart, and then copy the image of the files. But the holy grail is what is called hot backup. That is, the possibility to back up your database while active sessions are running and possibly changing the data. It all relies on the journal, which logs transactions so that a committed transaction is written to disk and can be restored in the event of a database crash. When you start your backup, the DBMS must record that it's in a special mode where it will maintain consistency while data files are saved. This is a key point. The DBMS must support hot backups, otherwise you'll end up with corrupted files that you'll be unable to restore. Then you copy the data files, but at the end you must copy all the transaction logs that have been written since the beginning of the backup. When you restore after a crash, you will not start up as fast as with the cold backup, because after copying the data files, you must apply all the transaction logs to them. But the really great thing is that you can also apply transaction logs that have been created since the backup, up to the crash. Or, if a human error was committed, up to a few seconds before the blunder, rewinding the clock and performing what is called a point-in-time recovery. When you rate a hot backup, consistency is okay, data loss can be minimal, and availability can be very good. If you have a spare server, you can make availability even better by using what is called log shipping. The idea is that you have on a spare machine a copy of your database restored from a hot backup, that you send to this machine, it's usually automated, the transaction logs as they are generated, and you replay them on this machine. No other changes than those that are replayed are reloaded on this server. If the primary machine crashes, you just have to switch to the standby server that is in the starting blocks, ready to go without a lengthy recovery. It's not a perfect solution either, because very often you will have a short lag between the moment a change happens on the primary database and when it is applied to the standby database. In the worst case, whatever happens during the lag can be lost. To protect yourself against hardware failures, you want to minimize the lag, and sometimes the two databases can be in sync. But if you have a human error, the standby database will be probably corrupted as well, because any blunder will probably be replayed before you can interrupt the replication. The conclusion is that very often you need to combine several backup methods to protect yourself against different types of incidents. Even a data dump can have its use if you only want to restore one table. And of course, it's a question of risk analysis and how much you are willing to pay for hardware, spare machine and such, to insure yourself against problems that may or may not happen. In any case, test your recoveries. It always works in the documentation. In the real world, when the database is down, when you are stressed and when your telephone keeps ringing, it's not as easy as the docs say, and you will feel better if you have already practiced it. Thank you for your attention.